Alright guys, this is the video lecture for chapter 24, which will cover how we go about measuring the cost of living. So in this chapter, look for the answers to these questions as we go along. First of all, what is the Consumer Price Index, or CPI for short? How is it calculated, and what do we use it for? Next, be looking for the answer to this question: what are the problems with the CPI, and how serious are those problems? Also look for this: how does the CPI differ from the GDP deflator that we learned in the last chapter? Also look for this answer: how can we use the CPI to compare dollar amounts from different years? And also, why would we want to do this anyway? And lastly, look for the answer to this question: how can we correct interest rates for inflation? And as it turns out, it's pretty straightforward. All right, so let's start by talking about the Consumer Price Index, what it is, and how to calculate it. So what it is it's a way for us to measure a typical consumer's cost of living. So an individual's cost of living could be, higher in one city and lower in another, say San Francisco, where the cost of living is much higher than Atlanta. So we could look at the CPI in San Francisco and in Atlanta and see that the CPI in San Francisco is higher, indicating that the cost of living is higher in San Francisco. One thing that it's used for very frequently is what's called a cost of living adjustment, or COLA, which COLAs are in lots of contracts as well as Social Security payments. So a lot of contracts and Social Security payments are automatically adjusted for inflation and other cost of living aspects. All right, so how then do we calculate this thing? Well, we start with a basket, okay? Just like a shopping cart or a shopping basket that you fill with your groceries, we use a basket to calculate CPI. Now, hopefully the connection between this basket and a grocery basket makes sense, but it's basically it's what the Bureau of Labor Statistics, or the BLS, uses to determine CPI, and they do this by basically surveying consumers to figure out what the average consumer or typical consumer's shopping basket consists of. So it's going to include things like food, obviously. It's going to include housing and energy costs, right? Things that most people consume. So they start with a basket, and then they find the prices of the things in the basket. All right, so the BLS collects data on the prices of everything in the basket once they figure out what the basket is. And then they compute the cost of the basket, right? So if you went to the grocery store, the idea here is that you go to the grocery store, and every time you go, you put the same stuff in your basket every time. And then when you check out, that's the price of the basket, right? When you go to pay and check out. Now, if that price is changing over time, basically what we can tell is, at say, let's say 3 months ago, your basket cost $100, and when you went shopping today, it cost $110. We can basically infer that there has been some inflation, or at least that the cost of living 3 months ago was less than the cost of living today. So that's the idea here, okay? Now, once we have the cost of the basket, we calculate the cost of the same basket in a base year. And so to calculate the CPI, we take the ratio of the cost of the basket in the current year divided by the cost of the basket in some base year, some year that we use for comparison, and then we multiply it by 100. So this should look familiar because we basically calculated the GDP deflator in almost the same way. It's just the definition, or the basket really is what's changed, because when we calculate the GDP deflator, the basket is the entire United States economy, or the entire country's economy, maybe not the United States, but whereas here, the basket is not going to be everything that's produced in the economy. It's going to be things that an average consumer buys. So it's not going to include things like, I don't know, freight trucks, right? Consumers don't buy big rig semi trucks, but businesses do. So big rigs would be in the GDP deflator, but it wouldn't be in CPI because a typical consumer does not purchase a big rig shipping truck. Okay. And then we can also use CPI to calculate the rate of inflation from year to year. And so basically what we do is we find the difference between the CPI this year and the CPI last year, and then divide it by the CPI from last year, and multiply by 100% to put it into percentage terms. All right, so let's look at an example here. So our basket, just to keep it simple, only has two goods in it, and that is pizza and lattes, as we've seen earlier from earlier chapters. And in particular, in the basket is 4 pizzas and 10 lattes. And of course, we have different years with different prices. So 2010, 2011, and 2012. And we see that the price of pizzas goes up by $1 each year, and the price of lattes goes up by 50 cents each year. All right, so to start, we just need to figure out the cost of the basket. So the price of pizza times the number of pizzas, so it's going to be $10 times 4. And we're going to add that to $2 per latte times 10 lattes. And so we get 40 plus 20, which equals 60. So the cost of this basket in 2010 was $60. We do the same thing for 2011, and we calculate that the cost of the basket in 2011 is $69. And again for 2012, and we get the cost of the basket going up yet again to $78. All right, so there's the cost of our baskets. Now we are ready to compute CPI, Consumer Price Index, in each year using 2010 as the base year. So remember that the base year is arbitrary. You can pick any year. You're just picking a year to use as the basis of comparison. So we're going to use 2010. So using 2010 as a base year, the CPI in 2010, since it's the base year, will of course be 100, because we have the price of the basket in the year of interest divided by the price of the basket in the base year. Those are going to be the same. So 60 divided by 60 gives us 1, and multiplied by 100 equals 100. So that's always going to be true in the base year. The CPI, or if it's the GDP deflator, same thing. Any price index, and there's many others than just these two, will be 100 in the base year. So that will always be true. All right, what about 2011? And just real quick, think to yourself, is it going to be higher or lower? Okay, take a guess based on the costs of the basket and what you remember from the previous slides. But guess. Hopefully what you guessed is that it's going to be higher because the prices of both pizzas and lattes went up. And if you guessed that, you would have been correct. But again, we're just using our CPI formula, so the cost of the basket in the year of question, which is 2011, $69, divided by the price of the basket in the base year, so $60. That would give you 1.15, and then multiply that by 100 to get 115. And so basically, this is really nice because we can immediately tell that there was 15% inflation from 2010 to 2011. And calculating the CPI for 2012 is basically the same thing. The price of the basket in 2012 divided by the price of the basket in the base year times 100. All right, and then since we now know how to calculate CPI and we've seen an example of how to calculate it using some real numbers, let's go on to calculating the rate of inflation using CPI. So if you'll recall, we just take the difference between 2 consecutive years and divide it by the earlier year. So if we were looking at the inflation between 2010 and 2011, we would take 115 minus 100 to get the difference there and divide by 100. And that's what we get, which gives us 15%, just like I said earlier. So the 15% is nice because it jumps out at us right away. We can see 100 to 115. Now, unfortunately, this only works when you're making comparisons to the base year, as we will see in the next inflation rate. So here, the difference between the inflation rates is not, the difference between the CPIs is not necessarily equal to the rate of inflation. That's only true when you're using the base year as the first or earlier year. So just to reiterate that, because as we can see here, the difference is the same, right? The difference between them is the same, but we're making now a comparison to 2011, so we're dividing by 115. So we're no longer using the base year and dividing by 100. We're using, basically, now we're using 2011 sort of as the base year, if you will, in a sense, when calculating the inflation rate, because it's an annual inflation rate that we're calculating. We could calculate the inflation from 2010 to 2012, and that would actually be 30% inflation. But if we wanted to calculate an annual rate, which is how it's typically calculated, we would want to, look at the inflation going from 2011 to 2012, and it would be 13%. Okay, so now that we've seen an example, take this opportunity to pause the video and compute these things, compute the CPI in 2011, and find the rate of inflation from 2011 to 2012. Okay, so go ahead and pause the video and try this out for yourself. All right, looking first at CPI in 2011. And of course, you should have noted, hopefully, you saw that you needed to use 2010 as the base year, so not much different. Our basket is different this time. It's not pizza and lattes, but beef and chicken, and particularly it's 10 pounds of beef and 20 pounds of chicken. So of course you needed that information to calculate the prices of the baskets. So you would have found the cost of the basket in 2011. You were already given the cost of the basket from 2010, so you didn't need to calculate that. And you would take those to calculate CPI in 2011, and hopefully you got 125. All right, and as far as the rate of inflation from 2011 to 2012, you would have had to calculate the cost of the basket in 2012 so that you can calculate the CPI in 2012. And once you got the CPI from 2012, you can then calculate the inflation rate by taking the difference. So the CPI in 2012 minus the CPI in 2011 divided by the CPI in 2011. All right. Trouble with that, maybe try a few more practice examples. You honestly could just make up your own numbers, but then I'm not sure how you would check yourself. But in any case, there should be some more practice on those types of questions in the book, and I can point you to those if you'd like. Just send me a text and ask me where those are. All right, so what is in the CPI basket? Well, here is a breakdown of some categories of what's in CPI. So starting with the top, we see that 15% of the CPI consists of food and beverage, 41%, the biggest percent, accounts for housing. Let's see, that dark blue accounts for apparel. A relatively large chunk, in fact, the second largest portion of the basket is transportation, medical care, recreation, education, communication, all roughly take up about the same 6 or 7%, and then other goods and services only 3%. So that's if you look at all those things, you should look at those categories and be like, yeah, that kind of makes sense. That's probably about roughly how I spend my money. So that makes sense that would constitute a consumer's basket, the average consumer's basket. All right. Next, we're going to look at some issues with CPI, some problems that it presents to us. So we're actually going to do that through an active learning exercise. Okay, so we're going to look at one problem called substitution bias. And so we go back to our basket of beef and chicken. Now, it could be that in 2010 and 2011, households bought this basket, right? 10 pounds of beef and 12 pounds of chicken. And maybe a rationale for that is that they were the same price in 2010 and they were the same price in 2011, even though they both went up in price. And so since the relative price between them didn't change, they didn't change their basket. But then in 2012, beef gets a lot more expensive than chicken. Okay, they're no longer the same price. So maybe households, in response to these price changes, would substitute relatively cheaper chicken for more expensive beef. So they in other words, consume less beef and more chicken in response to this type of price change. Maybe that's the case, right? Suppose, in fact, that they bought 5 pounds of beef instead of 10, and they bought 25 pounds of chicken instead of 20 pounds of chicken. So again, they increase their consumption of chicken and reduce their consumption of beef. Compute the cost of the 2012 household basket. So not the, let's see, not the CPI basket, right, but the actual household basket. We're given the CPI basket cost already. So go ahead and calculate what they actually bought and not what was in the CPI basket. And then also compute the percent increase in the cost of the household basket over the period 2011 to 2012 and compare that to the CPI inflation rate. Okay, so go ahead and pause the video and try to calculate these things. All right, so let's look first at computing the cost of the 2012 household basket rather than the CPI basket. Well, in that case, we're just going to multiply the prices of beef and chicken times their quantities in the actual household basket. So $9 per beef times 5 beef, which is 45, and $6 per chicken times 25 pounds of chicken, and that would give us 150. Add them together, and the cost is 195. Okay, so hopefully you're starting to see what substitution bias is, right? Because we had households substituting chicken for beef since beef got relatively more expensive, and because of that, they saved money compared to if they had stuck with the original CPI basket, right? The CPI basket cost $210, but the modified basket, the substituted basket, only costs $195. So if consumers do this and we don't calculate the actual basket that they purchased, but we use previous year's CPI baskets, we're kind of overstating the cost of the cost of living, essentially, right? Because consumers are intelligent and can manipulate their consumption to save money. And if we calculate the percent increase in cost of the household basket going from 2011 to 2012 and compare it to CPI inflation, we see this too, right? So the cost of living increase is actually lower than if we used CPI to calculate inflation. Okay, so here again is called substitution bias. So over time, some prices might rise faster than others, so their relative costs or relative prices change. And when that happens, consumers frequently substitute towards goods that become relatively cheaper, mitigating the effects of price increases, as we saw in the example. The CPI completely misses this substitution because it uses a fixed basket of goods that doesn't change, at least not frequently or in response to people's substitution. And thus, the CPI overstates the increases in the cost of living, just as we saw in the example. All right, so that's one problem with CPI, is called substitution bias. Hopefully you understand what it means after going through that exercise. Another problem with CPI is when new goods are introduced into the market, which happens all the time. New goods and services are being created all the time, right? Roomba vacuums were not a thing when I was in college, but now they are. So that's a relatively new product. Tesla cars, same kind of thing. Right? Again, there's new goods hitting the markets all the time. And so when this happens, when we have when we have the addition or introduction of new goods, it basically increases the variety of things available to us to consume. And it allows consumers to find products that more closely fit their needs. And what's happening effectively is that available dollars to a consumer, are becoming more valuable as the number of choices increases. Well, as it turns out, the CPI misses this effect too, because it again uses a fixed basket of goods, and again it's leading to an overstatement in the increase of the cost of living. So in both cases, with substitution bias and with the ignored introduction of new goods, CPI is being overstated. It's overstating the cost of living. Another problem is unmeasured quality changes. So over time, generally speaking, goods improve in their quality. And so a lot of those items in the basket, their quality is being improved upon over time. Now, as it turns out, the Bureau of Labor Statistics tries to account for quality changes, but it can, obviously potentially miss some, and that's mainly because quality is something that's hard to measure. And once again, third time in a row, CPI again overstates the cost of living as a result of this problem. So 3 cases of overstating the cost of living, the increase in the cost. Okay, each of these problems causes the CPI to overstate cost of living increases. Now, the Bureau of Labor Statistics is aware of these problems. Okay, it's not like it doesn't know about these. And it has made technical adjustments over time. It has tried to correct for these issues. But honestly, the CPI probably still overstates inflation by roughly 0.5% per year. Now, why do we care? Why is this important? Well, it's important because of those contracts and Social Security payments that have COLA, cost of living adjustments, tied to CPI. Okay, so basically, this is good for people that receive Social Security, and it's good for people that are on the receiving end of these contracts that have COLA clauses, that have cost of living adjustments. But there are losers, right? So the people paying the money, in Social Security, in the case of Social Security, the government is paying more money than it really should be to adjust for the recipients of Social Security and their cost of living adjustment, since CPI is overstating the increases in the cost of. So winners and losers there. And just to look at this over time, we have in red the GDP deflator, which very accurately calculates inflation because its basket is the entire economy. And then, of course, CPI. So you can see that it closely follows actual economy-wide inflation, but in many cases, at many times, it overstates, and occasionally it understates, actually. As you can see, there's a couple times where it dips below the red line. The blue line dips below the red line. But you can see, very obvious overstatement is right around 1980, 1982, where CPI was much higher than the GDP deflator. All right, so just comparing these two price indexes, we can think about imported consumer goods. Now, this imported consumer goods would be included in CPI, but they would be excluded from GDP deflator since they are not made in the country's borders. And the GDP deflator basket is everything made inside the country's borders. As far as capital goods go, so these are goods like machines and buildings, those would not be included in the consumer price index because consumers don't buy things that businesses buy, right? Like machines and warehouses and buildings and things of that nature. But capital goods are obviously included in GDP as long as they're produced domestically, right? That's an important note. Thinking about the basket, the contrast between CPI and GDP basket, well, of course, CPI uses a fixed basket of consumer goods, whereas GDP, the GDP deflator, uses a basket of currently produced goods and services. And the important point here is that this will matter if different prices are changing by different amounts. Most importantly, if consumer type goods are changing in ways that are different from other goods and services in the economy, perhaps capital goods are maybe not increasing as prices rapidly or something like that, that's basically when it would matter. All right, so just real quick, here's a exercise to really make the differences between CPI and GPI, GDP deflator rather, stick out to you. So in each of these scenarios, determine the effects on the CPI and the GDP deflator. Scenario A, Starbucks raises the price of Frappuccinos. Scenario B, Caterpillar, which is a manufacturer of bulldozers and those sorts of things, they raise the price of the industrial tractors it manufactures at its Illinois factory. And C, Armani raises the price of the Italian jeans it sells in the U.S. Okay, so think about the effects on CPI and the effects on GDP deflator. All right, so looking first at Starbucks raising the price of Frappuccinos. Well, since we're assuming that the Starbucks are made domestically here, so that affects GDP deflator, obviously, because it's made in the country's borders. And this is something that a consumer would purchase, so it would be included in CPI. So both the CPI and the GDP deflator would both rise. Caterpillar raising the price of the industrial tractors that it manufactures in Illinois, which obviously is in the within the borders of the U.S. So this would affect GDP. It would increase GDP deflator, but it would not affect the CPI since consumers do not purchase tractors, industrial tractors. And scenario C, Armani raises the price of the Italian jeans it sells. Well, these are not produced in the U.S., so would not be part of the GDP deflator, but this is something that consumers would purchase, so it would be part of CPI, so the CPI would increase and the GDP deflator would remain unchanged. All right, great. Now that we know a good way of calculating the cost of living and comparing the cost of living over different years, as well as calculating the CPI rate of inflation, we're going to now talk about ways to correct certain variables for inflation. So one example of this would be perhaps we would like to compare the dollar values of figures, the cost or the price of something at different points in time. Okay, so maybe a Mustang in 1968 versus a Ford Mustang in 2019. Well, inflation makes it hard for us to compare dollar values from different times because part of the reason for the change over time is inflation. But we might want to control for this. We might want to eliminate the change that has to do with inflation so we can isolate the change that comes from things that aren't related to inflation. So an example might be the minimum wage, right? So think about this. The minimum wage was $1.25 in December of 1963. In December of 2013, it was $7.25. So a question you might be interested in asking or getting answered is, did minimum wage have more purchasing power back then in 1963, or does the minimum wage have more purchasing power in 2013? In order to make a comparison between the different years, we need to use the CPI to convert the 1963 figure into 2013 dollars. So basically what we're going to do is use 2013 sort of as the base year. In other words, the basis of comparison. And this is the formula to calculate the amount in today's dollars using the amount in the amount of dollars in some other year t. And so we're gonna use this equation here to do that. So in our example, year t is December 1963, and today is December 2013. So the minimum wage again in year t was $1.25, and the CPI in year t was 30.9, and the CPI today is 234.6. So using these numbers, we can figure out what was the value of minimum wage in 1963 in terms of dollars from 2013. And in this way, we will basically ignore the level of inflation that's taken place. All right, so what you should be doing is taking $1.25, multiplying it by the price level today, divided by the price level in year t. There you go. And what you have is $9.49. So what does this mean? It means that minimum wage in 1963 is worth $9 and almost $9.50 in 2013 dollars. All right, so what does that tell you then about minimum wage in 2013? People earning minimum wage in 2013 are worse off than people earning minimum wage in 1963. Even though minimum wage in 1963 was only $1.25 in 1963 dollars. If they were earning 2013 dollars, they'd be earning $9.50 an hour, which is a dollar. What is that? $2.25 better than 25, which is the minimum wage in 2013. Now, why is it important for us to make these types of adjustments? Well, researchers, business analysts, and policymakers need to be able to make comparisons over time while ignoring the effects of inflation. And so very frequently they're going to use this technique to convert, say, a time series, which is basically just a bunch of observations over time of current dollar values, or in other words, nominal dollar values, and they can use this technique to turn it into constant dollar values. So looking at prices going all the way back to 1920, but in terms of 2013 dollars in all of those years, rather than looking at 1920 and 1920 dollars, etc. And by looking at it in a constant dollar figure, we are eliminating the effect of inflation. Right? So in other words, we can see how a variable has changed over time after correcting for inflation, in other words. And the example was the minimum wage. Let's look at that over time. So if we looked at minimum wage in current dollars, obviously it's always getting higher, right? Every so many years, Congress votes to increase the minimum wage. And the most recent increase was back in 2008, I believe, up to $7.25 an hour. $7.25 an hour. So there it is, just going up, never going down. But that's current dollars. So we want to control for inflation. And once we do that, we get dollars per hour, minimum wage in terms of dollars per hour of constant dollars. So using 2013 as the basis. So as you can see, it goes up sometimes and sometimes it goes down. And so basically it goes up for the most part when there's an increase in the current dollar minimum wage. But then after those increases, it slowly decreases because of inflation, right? Minimum wage is staying fixed for a period of time, which are these flat parts on the brown curve, right? And during those flat parts, the real minimum wage is slowly declining because inflation is pushing prices up. And cost of living is going up while minimum wage stays the same for some period of time. But there you go. So in recent history, going all the way back to 1990, right, minimum wage has been less than it was pre-1984, 1985, right? In the period 1960 to 1985, real minimum wage was up above $8. And keep in mind, $8 from 2013. Okay, now that we're in 2020, those $8 would be worth less, but $8 from 2013, right? And then beyond 1983, 1984, the minimum wage dropped below $8 2013 dollars and has kind of bounced off of $6. So bouncing kind of between $6 and $8. So that's interesting. If you were a minimum wage earner, you were doing better back in 1970, 1960 before than you were today. All right, so let's do an active learning exercise here, comparing tuition increases over time. So we're going to look at tuition and fees at U.S. colleges and universities, and we're going to be looking at the differences in 1990 compared to 2013. And different types of universities. So we've got private, nonprofit, 4-year institution, a public 4-year institution, and a public 2-year institution. And looking at the differences here. We also have CPI as a reference. So what you want to do is express the 1990 tuition figures that are given here in terms of 2013 dollars using the formula from a few slides back. And then compute the percentage increase in real terms for all 3 types of schools. Okay, so those are 2 different steps for each different type of school. And then try to figure out which type of school experienced the largest increase in real tuition costs. All right, so go ahead and pause the video and take about 10 or 15 minutes to calculate those things. All right, so here we go. Here are the figures. So hopefully this is what you got. If we need to, I can go over this in class next time we meet. That'll probably be helpful for everybody, but here are the answers, so you can pause and take a look at them. But as we can see, for private, nonprofit, 4-year colleges, the real tuition and fees in 1990 were $16,622 in 2013 dollars. The public 4-year was $3,396, and the 2-year public school was $1,612. And once you calculated the percent differences or the percent increases, you can see that public 4-year schools have had the largest increase. All right, so when we correct variables for inflation like we just did, it's called indexation. And a dollar amount is indexed for inflation if it is automatically corrected for inflation by law or in a contract. So COLAs are a form of indexation. So for example, the increase in the CPI automatically determines the COLA in many multi-year labor contracts, adjustment in Social Security payments, as well as federal income tax brackets. So all of these things are indexed. And the last thing we're going to look at is correcting variables for inflation when we're talking about interest rates. So it's slightly different. In fact, it's a little bit easier in this case. So we've already corrected prices and dollar values for inflation, but now we're going to correct interest rates for inflation. And so when we talk about interest rates that have not been corrected for inflation, what we are talking about are nominal interest rates, right? Interest rates not corrected for inflation. So if you went and looked at a car loan or a loan on a house or anything like that, what you would be finding are nominal interest rates. And if I haven't mentioned it already, nominal interest rate is really a price. It's the price of borrowing money. And the nominal interest rate is the price or the cost of borrowing money without accounting for inflation, not corrected for inflation. And what it is it's the rate of growth in the dollar value of a deposit or a debt, right? When someone loans money, they are paid interest. So the price of borrowing money. Now, once we correct the nominal interest rate for inflation, now we have the real interest rate. It's the interest rate that has been corrected for inflation. And what it is it's not the growth in the dollar value of a deposit or debt, but it's rather the rate of growth in the purchasing power of a deposit or debt. Okay? And what we really care about is not the dollar value, we care about purchasing power. How much can our dollars buy for us? Not how many do I have, right? And like I said, calculating the real interest rate is very straightforward. You just subtract the rate of inflation from the nominal interest rate. So the real interest rate is equal to the nominal interest rate minus the inflation rate. All right, so let's look at an example. So suppose that you deposit $1,000 for 1 year, and in return for your deposit, you get a nominal interest rate of 9%. And during that year, inflation is 3.5%. So what this means is that you would get $9 for every $100 you have deposited, which means you would end up with $90 in interest at the end of 1 year. So in your bank account would be $1,090 at the end of 1 year. So that's the value, right? That's the nominal value. You have $1,090 at the end of the year. But because prices in the economy rose, that doesn't mean that your purchasing power went up by 9%. It went up by less than that. In fact, the amount that it went up by is the real interest rate. And to calculate that, we need to take nominal interest rate and subtract inflation, which is 9% minus 3.5%, which gives us 5.5%. Which means that the purchasing power of your $1,000 deposit had grown by 5.5%, not 9%, even though you got 9% more dollars at the end of the year. And just to see the difference over time, going all the way back to 1950 and up to 2015 or so, we can see that the nominal interest rate is always higher for the most part than the real interest rate, except for a few brief moments. Looks like maybe right around 1950, the real rate was actually higher. In 1955 or 56, looks like for a second the real interest rate was higher than the nominal rate, and then it happened again during the Great Recession in 2008 and 2009. Now, I challenge you to think about what it means when the real rate is greater than the nominal rate. If the real interest rate is greater than the nominal interest rate, then what has to be true? I expect you to tell me next time we meet. I'll ask you in class when we meet next Saturday. Okay, so just to summarize, we learned about what the Consumer Price Index was. It's a measure of the cost of living. We saw that it tracks the cost of a typical consumer's basket of goods and services. We saw how the CPI is used to make cost of living adjustments, or COLAs, and it's also used to correct economic variables for the effects of inflation. And then we wrapped up the chapter by seeing that the real interest rate is corrected for inflation by simply subtracting the inflation rate from the nominal interest rate. All right, so that is the video for chapter 24. Make sure you're keeping up with your homeworks, and I will see you in class very soon. Thanks for watching.